Hello friends, welcome to this session. So after completion of the lines, the equation of lines in the parametric form, non-parametric form, in the Cartesian form, now it's time to understand the next concept, the new concept. What is that? The distance of a point from a line. How we can find out the distance between the point and line. This concept we have already discussed in the straight lines in the two-dimensional space. The same concept is applicable here. Okay, so for that purpose we have one theorem 6.5, which is very simple, with which we can easily find out the distance of a point from a line. Okay, so let me write down here the theorem number 6.5 statement. The distance of a point, the distance of point P in bracket alpha bar from the line r bar is equals to a bar plus lambda b bar is given by under the root mod of alpha bar minus a bar whole square minus alpha bar minus a bar dot b bar upon mod of b whole square. Okay, do not worry about this formula. I will explain you each and every term of this formula. This is very simple formula. Don't look at this formula as it's very difficult to remember. No, it's not. Once we prove this theorem, then you will understand the concept and you will understand the way we can remember this formula. Okay, so let's get started. Let's see how we can prove this. Okay, so let me have some space here so that we can draw the figure. So let's take this point P having the position vector alpha bar, and suppose this is the line we have, the L bar. Oops, sorry, it's R bar. Okay, so this is R bar is equals to a bar. Oh, this is R bar is equals to a bar plus lambda b bar. Okay, I hope you remember what is a bar and what is b bar in the equation of line. This is the perpendicular equation, and suppose this is the point M. Okay, what is a bar is? A bar is the point lying on the line. Okay, so let me take that point here, A. Okay, having the position vector a bar. And what is b bar? B bar is the vector parallel to the line. Okay, now if I join the A and P, what I will get is, see here, if I join this AP, I will get AP bar. So this AP bar and this is AM bar. Okay, now we have stated one concept in the vectors. What is this AM is known as? In this triangle APM, what is this AM is known as? AM is nothing but the projection of a point, sorry, the projection of a vector AP bar on the vector B bar. Okay, so you say on the vector B bar or you say on the vector of this line, no problem. Okay, so the AM is nothing but here AM bar is nothing but is projection of AP bar on B bar, and the projection rule says that projection AM bar is given as AP bar dot B bar upon mod of B. Is it okay? I hope you remember this. Okay, put this equation number 1. Now in the triangle APM, what is AP square is equals to? AP square is equals to what? It is AM square plus PM square. AM square plus PM square. And what you want? I want the distance between the point and line, which is nothing but this length of PM I want. Okay, so let's rewrite this equation in terms of PM. So PM square is equals to AP square minus AM square. Okay, so AP square means what? It is a P bar minus A bar. So it is a P bar minus A bar whole square minus what is am square. Am square is nothing but we have the am, we have this am, and let's substitute. Okay, I will keep this as it is, so it is a am square, so which is nothing but, now what is p bar actually? P bar is nothing but alpha bar. We have considered that the position vector of p bar is alpha bar, so this is equals to alpha bar minus a bar minus what is am bar is? Am bar is nothing but ap bar dot b bar upon b. Okay, so this is nothing but ap bar dot b bar upon mod of b, you can say, or simply b you can write, no problem. Okay, and if I rewrite this ap bar again as a alpha bar minus a bar, I will get the same equation, alpha bar minus a bar. Okay, I remove this, forgot to write this square. Okay, so this is nothing but you have alpha bar minus a bar dot b bar upon b whole square. This is nothing but the pm square, plus we want pm. I don't want pm square, I want pm. So let's square root on both sides, so you will be getting, so pm is equals to under the root of, it's very simple, alpha bar minus a bar square minus of alpha bar minus a bar dot b bar upon b. Okay, iska square. I hope it is clear. So in this way you can prove that the distance between the line and plane is always equals to the square root of alpha bar minus a bar whole square minus alpha bar minus a bar dot b bar upon b. Now the question is, sir, how we can remember this formula is? See here, if you observe this formula, it is having only two terms. Okay, the first term is alpha bar minus a bar, this is the alpha bar minus a bar, and the second term is what? You have the b bar. That's it. You take its square and you take its square. You require alpha bar minus a bar square and you require b bar b square. Okay, you remember, you require all these things. Okay, b square means indirectly I am telling you, so this b square. Okay, that's it. So the alpha is nothing but the given point, a is the passing through point, and b bar is the parallel vector. That's it. It's very simple. So it's alpha minus a bar, or you can write like this. You can keep the some one notation for this alpha bar minus a bar is, let's say let's take m bar. So your pm bar, which is the distance between 2 points, becomes what? It is m square m bar square minus m bar dot b bar upon b, it's a square. Now again you can simplify this. What is the vector divided by its magnitude? What is the vector divided by its magnitude? It is b cap, unit vector. Okay, so how you can rewrite again pm equals to, so pm bar equals to what? It is root of m bar square minus m bar dot b cap whole square. See the two equations we can form. The first equation, standard one. The second equation, just having the notation for alpha minus a, and this is what in terms of the unit vector of b. I hope it is clear to everyone. Okay, don't worry, it's very simple. Once we take one simple example, you will get it. Okay, so why to delay? Let's directly start the question. So the question is like this. Example. Okay, so the first question is like this. Find the length of perpendicular. Find the length of perpendicular drawn from the point okay, P in bracket 3, 2, 1 to the line r bar is equals to 7i 7j 6k, 7i plus 7j plus 6k plus lambda into bracket minus 2i plus 2j plus 3k. Okay, so we have to find the length of perpendicular drawn from this point to this line. Okay, let's draw figure so that it will be clear. So this is the point P given, and this is the equation of line. Okay, so we have to find out this perpendicular distance. Okay, so this is P, means what, in the theorem we have seen this becomes our alpha. We have some point A here which is our A bar, and we have the equation of line which is having the B bar. Okay, so you require two terms in this equation, which is alpha bar minus A bar and B bar. Okay, so in the equation of line, what is A bar? This first part is A bar, that this is we are seeing from the first day of the equation of line, from first day of this chapter. Okay, and this is what the B bar is, and this is what the alpha bar is. Okay, so make sure that you are getting these terms, because getting these terms is very important. If you interchange this alpha bar and A bar ना, खत्म हो गया सब. Okay, no need to solve. भाई उधर ही wrong हो गया, तेरा आंसर ही नहीं आएगा, तेरा wrong हो गया, 0 mark. Okay, so please make sure that you are having the same notations. Okay, so we know that the PM bar is equals to, or the PM mod of PM is equals to root of alpha bar minus A bar whole square minus alpha bar minus A bar dot B bar upon B whole square. So you require two terms. Which are those two terms? Alpha bar minus A bar and B bar. Okay, so first to find out alpha bar minus A bar, which is nothing but 3i plus 2j plus k. So 3i plus 2j plus k, and what is A bar is 7i plus 7j plus 6k. Okay, so it will be 3 minus 7 is minus 4i, 2 minus 7 is minus 5j, and k minus 6 is nothing but minus 5k. This is my alpha bar minus A bar. Find out its magnitude. Okay, so mod of alpha bar minus A bar will be equals to what? It is the root of 4 square is 16 plus 25 plus this is 25, which is nothing but 66. Okay, and what will be the square of this? So alpha bar minus A bar, its square is equals to 66. See here what you get first part, you get the second term, the first term and second term. Now you have the B bar. In the question itself they have given this B bar. Okay, this is what B bar is. So B bar is equals to minus 2 plus 2 and 3. Minus 2 plus 2, 3. Now B bar is equals to given minus 2i plus 2j plus 3k. Okay, so what will be mod of B, which is equals to root of 4 plus 9, which is nothing but 4 8 and 9, it's a 17. Okay, 17. You require B square again. Okay, so the B square is equals to 17. Now substitute these values in the formula. So it will be equals to, so the PM is equals to, root of alpha bar minus A bar whole square minus alpha bar minus A bar dot B bar upon B whole square. Okay, so substitute the values and you will get alpha bar minus A bar is how much? It's a square, is nothing but 66. Okay, so this is 66 minus, in the numerator you have the dot product of two vectors, which is alpha bar minus A bar. So this vector and this vector, you have the dot product of these two vectors, and then the dot product you get only I, jj and kk terms. So I will write down directly here. So the I will be what? It is minus 4 into minus 2, which is nothing but 8. Okay, so we have bracket here, 8 minus 5 plus 2, so it is 10, minus 5 into plus 2, it becomes minus 10, and at the end we have minus 5 into plus 3, which is nothing but minus 15. Okay, divided by mod of B is what? It is a root of 17. Keep this as it is, square. Okay, now let's solve this, which is equals to root of 66 minus how much it is? So it is minus 2 and we have minus 2 minus 15 is minus 17. Minus 17 upon root 17 is nothing but minus root of 17 whole square, which is nothing but 66 minus 17. Okay, so how much root 66 minus 17 is nothing but 49. So root of 49, which is equals to 7 units. Okay, so what is the distance between these two things? That is a line and a point. This is nothing but the 7 units. See how beautiful it is. We can find out, we can use the mathematics to find out the distance between the line and point. Okay, the concepts which are given here in this topic are very beautiful, excellent. Okay, so in this way we can find out the distance between the 2 points. You may find this calculation bit difficult, but don't worry, after doing some practice, after solving a few more questions, you will find it is very easy. Remember that you have only two terms here, alpha bar minus a bar and a b bar. That's it, more than sufficient. Okay, very good. Now we will take one more example and we will stop here. Let's take the same example of finding the distance between the line and plane, but this time we will use the Cartesian form. Okay, the previous one was the vector form because we had their ijk terms. Now we will see the Cartesian form. Find the distance of a point. Find the distance of point P in bracket 0, 2, 3 and the line x plus 5 by 3, sorry, x plus 3 by 5 equals to y minus 1 by 2, x plus 3 by 5, y minus 1 by 2 and z plus 4 by 3. We have to find out the distance between the point and line. Now see, we will not make use of that theorem. There is another concept with which we can solve this question, and that concept is very good, very nice concept we have. Suppose this is a point P and this is the given equation of line. Okay, now tell me what you call this point. This is nothing but the foot of perpendicular of PM bar. Okay, this is a foot of perpendicular of PM bar. Draw the perpendicular PM bar to the line. Let's write that. Draw PM perpendicular to line. Okay, let's see what approach we are using here. What we are interested to find out the distance between this point and line. Means what? We want to find out the PM length. Okay, and the coordinates of P are given 0, 2, 3, and let's say the coordinate of M are what? x1, y1, and z1. Now using this we can easily find out using the 2-point form. Yes, the PM can be calculated easily, which is nothing but x1 minus 0 whole square plus y1 minus 2 whole square plus z1 minus 3 whole square. With this we can easily find out the distance between the point and line. But now the task is how you get these points x1, y1, z1, how you get these coordinates. Now you told that the M is the foot of perpendicular. Okay, so what is M is? It is nothing but the foot of perpendicular, because we have drawn the perpendicular from P to the line L. So it is foot of perpendicular. Okay, and also this M is lying on the line. Means what? It should satisfy that equation of line. And in the last video we have seen that how we find out the any general point on the line. So let's take M in bracket x1, y1, z1 be any general point on the line and its coordinates are given as yes, get the equation first, which is x plus 3 by 5. Okay, So it is x plus 3 by 5, which is equals to y minus 1 by 2, which is equals to z plus 4 by 3. Okay, it is equals to lambda. So this is the way we can find out the any general point coordinates on the same line. So x becomes what? X is equals to 5 lambda, oops, it is a 5 lambda array, 5 lambda minus 3, y becomes 2 lambda plus 1, and z becomes 3 lambda minus 4. So these are the coordinates of point M. I can easily take. Okay, so it is 5 lambda minus 3, y, oh why don't y, it is 2 lambda plus 1, and it is a 3 lambda minus 4. This is what we have the coordinate of the point M. Now how to get the value of M, sorry, how to get the value of lambda? Okay, if you get the value of lambda, then we can get the directly the coordinate of this point. Okay, now see here, the point PM, so the vector PM bar and this line, okay, these are what? Perpendicular to each other. Okay, so these are what? The perpendicular to each other. Now again we have seen that the perpendicular vectors direction ratios relationship. And what is that? If suppose I take a1 b1 c1 are the direction ratios of the vector PM, a2 b2 c2 are the direction ratios of the given line, or you can say these are the direction ratios of the vector line, okay, b bar, which is parallel to this. But in this case the direction ratios of the line is directly given, which is a 5, 2, 3. Okay, now what is the relation between these two direction ratios? We have already seen that if the vectors are perpendicular to each other, then the relation between the direction ratios is what? For perpendicular vectors, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. This is what we have. Okay, then tell me how you get the direction ratios of this PM, which is nothing but x2 minus x1, y2 minus y1, and z2 minus z1. These are the direction ratios of the vector PM. Okay, so x minus 0 is A, y1 minus 2 is B, and z1 minus 3 is a C. Okay, so let's write down that. So I will write down here everything. So A1, B1, C1 are the direction ratios of DRs of PM, and the point P coordinates are, it is 0, 2, 3, 0, 2, 3. So the direction ratios is given by, so M coordinates क्या थे अपने? M coordinates are nothing but 5 lambda minus 3, 2 lambda plus 1, 3 lambda minus 4. Okay, so take this direction ratio is what? It is x2 minus x1, 5 lambda minus 3 minus 0. So direction ratios are what? 5 lambda minus 3 minus 0, 2 lambda plus 1 minus 2, and 3 lambda minus 4 minus 3. Okay, so this is what the direction ratios of the line PM. So if you simplify this, you will have 5 lambda minus 3, 2 lambda minus 1, and 3 lambda minus 7. These are the direction ratios of PM. And we already stated that the perpendicular vectors direction ratio relationship is that the summation of multiplication of the DRs is always equals to 0. And the A2, B2, C2 are values given here, which is 5, 2, and it is 3. 5, 2, 3. So let's take given A2, B2, C2 are nothing but 5, 2, 3. Therefore, from star equation star, this, from equation star, what we have? A1, this is my A1, this is B1, and this is C1. So A1, A2, so 5 lambda minus 3 into A2, 5, plus 2 lambda minus 1 into 2, plus 3 lambda minus 7 into 3, this is equals to 0. Okay, so solve this equation. So 25 lambda minus 15 plus 4 lambda minus 2 plus 9 lambda minus 21, it is equals to 0, which is equals to, so it is 25 plus 4 29, 29 plus 9 is 38, so it is 38 lambda. So we have minus 17 and it is minus 31, so it is minus 38, which is equals to 0. So lambda कितना आ गया बॉस? So lambda is equals to, ये आ गया 38 by 38 आ गया 1. Once you get this lambda equals to 1, we can substitute here now lambda equals to 1, and you will get 5 into 1 is 5 minus 3, comma 2 plus 1, comma 3 minus 4, which is again equal to 2 comma 3 comma minus 1. So what are the coordinates of m you get? It is 2 3 minus 1. It is 2 comma 3 comma minus 1. Okay, now you make use of this pm, which is the distance formula, and you will get the answer. So let's write down here only. Okay, let's start here only. So the under the root of x1 minus 0, so x1 कितना है अपना 2 है, so 2 minus 0 is 2 only, उसका square, so 2 square plus y1 is what, it is a 3 minus 2, 3 minus 2 whole square plus minus 1 minus 3, minus 1 minus 3 whole square, which is equals to, again it is the root of 4, 3 minus 1 is 1, 1 square is 1, and plus minus 3 minus 1 minus 4 whole square is 16. Okay, so this is 16 and char 20 and plus 1 is 21. So root of 21 is my answer. Okay, see, for explaining this question it takes near about 10 to 15 minutes, but trust me, the concept is very simple. If you do on your own, it should not take more than 5 minutes. Okay, so the concept what we have used here is, I will just revise everything in just a minute. Okay, what we have used is, we want to find out the length of pm. So for that purpose we knew the coordinates of point p, but we didn't know the coordinates of point m. Then we do the calculation to find out the coordinates of m. How? We make use of the relation between the direction ratios of the perpendicular lines, and we have taken a1 a2 b1 b2 c1 c2 addition is equals to 0, and we have taken this m is in a general random point on this line. That's why we have considered the coordinates of the point m in terms of lambda. Okay, and using all these three conditions we get the equation of line, sorry, the distance of this pm. I hope this finds good to everyone here. Don't think that this question is very lengthy or it is very confusing. सर वेक्टर का फॉर्मूला भी बहुत डिफिकल्ट है, और आपने जो कंसेप्ट बताया यहाँ पे जो कार्टेशियन का, दैट इज आल्सो वेरी डिफिकल्ट. नो, नॉट एट ऑल. These are very simple, because in the next video we will be solving so many questions which are based on this. There you will be getting the concept very clear, because we will be solving the questions step wise, step 1, step 2 and so on. Okay, so make sure that you are having each and every concept clear. Okay, so with this we will stop here and we'll meet in the next video. Thank you so much.